Okay, so we are going to look at what's happening for a visual pattern. We're going to draw the next few in the pattern, and we're going to go ahead and do some graphing and table making and figuring out from the pattern. Okay, so we've done this a little bit before. I think we did one just the other day in our review. So first things first, it says that we need to use our resource page, and our resource page is down below. Oh, correction, where'd it go? Oh no, I'm silly, it's right here. It's this graph paper that's right here at the top. Forget it. Tomorrow it says stuff down below. Okay, so we're gonna do figure 0. We're gonna figure out how did it start? Did it start looking like? And we're gonna figure out figure 4. Where is it going to? Okay, so we need to talk a little bit about what do we see is going on right now? What do we see is going on right now for figure 1 to figure 2? What is changing from figure 1 to figure 2? What did they do different? Gage, I need to see more of you. You know better. So what is happening? What's changing from figure 1 to figure 2? Vanessa, Sergio, come on. What's happening from figure 1 to figure 2? Someone tell me, what do they see is happening? What's changing? Did they add any rows to the top and bottom? Okay, we need to be more specific than it just increase. We need to start talking about where things are added, how many are added, which direction. Is it up, down, left, right? We need to get specific. Obviously, we see it's increasing because it's getting bigger. So we need to look, what is actually happening? What are they adjusting? Where are they adding stuff? What is going on? So from figure 1 to figure 2, what's going on? Be specific. I don't know why I have to keep saying that. It's adding on, it's putting more figures. That's not helpful. That gives no information. What is going on? What changed? Where did it change? What changed? Where did it change? Okay, so we added some to the middle. How much to the middle? So from middle, no, I'm going to use my line. Why am I trying to make it difficult on myself? Okay, for the middle, I see that something changed in the middle, right? What changed in the middle? How much? Okay, so we added 2 to the middle. All right. So we added 2 to the middle. Did anything else change? I'm going to take this guy off. Did anything else change? Where else did they add stuff in? Remember, rows go side to side, columns go top to bottom. So if they add something on the left or on the right, that means they're adding columns. If they add something to the top or bottom, they're adding rows. So what change happened actually? What happened? And what happened? And I'm gonna move this +2 just a smidge. Because I see there's changes there, right? Everybody sees that changes happen to the top and to the bottom, right? So what changes happened? What changes happened? The middle added 2, but what happened to the top and the bottom? What did they do? And where did they add it? Did they add a row or did they add a column? Did they add a row or did they add a column? Well, did they add a row? That means it went higher up or down. Or did they add a column? It went more left and right. Okay, so the top was 2 columns and then it went to 3 columns. So we added a column of 2, right? We added a column of 2. So first thing I'm going to say is do the +2, and then I'm going to say the word column. We added 2 as a column, not a row, because rows go adding to the height, columns add to the width. So this was a column, oops, not black, only blues and reds. Column of +2 went to the top. Did the bottom do the same thing? They added a column of 2. Okay, so if we look, if I go and I highlight in figure 2, the figure 1 stuff, okay? I'm going to highlight in figure 2, the figure 1 stuff. Figure 1 had 4 boxes on the top, right? Figure 1 had 1 box in the middle. And figure 1 had 4 boxes on the bottom. Okay. Did the bottom do the same thing as the top? Did the bottom do the same thing as the top, where it added a column of 2? Did the bottom do the same thing as the top? Because we added a column of 2. Yes. Okay. So then I'm going to repeat this that I said. I have a +2 here. +2 is how big. And we're going to do the text box to say that it was a column of +2. COL. Right? To remind us, it's a column of +2, not a row. Because a row would be going higher, not wider. Okay, so if it goes wider, it's column. If it goes taller, it is row. Okay, wider is column, taller is row. Okay, so let's go look. Let's highlight in figure 3 what figure 2 has. So let's go to figure 3. I'm going to change my color. I'm highlighting inside figure 3 what figure 2 has. Figure 2 has 3. So figure 2 had 3. Right? And then it had 3 boxes. So 1, 2, 3 boxes. That's about as good as it's going to get me. And then it had a 3 again. Okay. So we look. Did figure 2 to figure 3 do the same thing? Did the middle add 2? Did the middle add 2? Yes, so we could say plus 2 here. Plus 2. Okay. Did the top do the same thing? A column of 2. Yes, so we can say column, and we can say plus 2, right? I'll put them over here and then move them. Right? Did the bottom do the same thing? Did the bottom do the same thing? Yes. So we can do the plus 2 again. And we say it's a column. Now, someone already noticed earlier, and I didn't ignore it, I just was waiting for the moment that it's an appropriate answer. Yes, we're increasing each shape by 6, but we have to be specific about where we're increasing our shape. Okay, where we're increasing our shape. All right, so we have to be specific about where we're increasing our shape. Okay. All right, so now we have to backtrack. We have to backtrack to figure 0 and forward track, pardon me, and forward track to figure 4. Let's do figure 4. Let's move forward to figure 4. Let's see. So I know that I need to have the same shape as figure 3, right? But I have to have 2 more higher in the middle, and I have to have 2 more on each of the fronts to make it a bigger C than it already is. So how many is my middle going to have for figure 4? How many is the middle going to have for figure 4? The middle has 1, 2, 3, 4, 5 right now, right? That's the middle. So how many is this middle going to have? If we're doing plus 2 to the middle. No, we're going to have 7. Okay. And then I have 2 above. So I got to leave myself space for 2 above. So 1, 2. That's the beginning of this column, this little box part at the top. And then 7 more. 1, 2, 3, 4, 5, 6, 7. And then I need my bottom 2. 1, 2. Don't like that one. 2. Okay. So that would be this whole upright of the C. Now we just have to build out. How much more out do we need to put? This one had, figure 3 had how many across the top? Figure 3 had how many across the top? How many did figure 3 have across the top? How many should figure 4 have across the top? See what it's doing. Figure 1, 2, figure 2. Figure 3 has how many across the top? 4. So figure 4 should have how many across the top? 5. So I have 1, 2, 3, 4, 5, right? And I know it's too tall, so I'm going to go repeat that down below. And I know it does the same thing at the bottom. 1, 2. Not perfect, but it works. I don't like those last 2 because they mirrored each other, right? Okay, so we still have to backtrack and figure out figure 0, though. And figure 0 is supposed to have how many total boxes less than figure 1? So let's look at how many boxes we have. How many boxes are in figure 1? Let's see how many we have to start. How many boxes do we have in figure 1? 9 boxes. Okay. So how many boxes do we have in figure 2? Tony, camera. How many boxes in figure 2? 15. How about figure 3, guys? Okay, and then figure 4, we figured out after we drew it, has how many? $27. Okay. So now we have to think about it. What do we see is happening between? We see that each one's adding 6 on, right? We talked about that already. Each one's adding 6 on. So if I subtract 6 from my 9, I should have how many in figure 1? Only 3. Okay. So then we got to start thinking about, okay, well, how does that configuration happen so that there's only 3? So figure 2 was how many columns wide again? How wide is it? So figure 1 is how wide? Nope, 1 second. So I'm asking this question right here. How wide is it? How wide is it on this one? And how wide is it on this one? And how wide is it on this one? So figure 1 is how wide? Too wide. Figure 2 is how wide? 3 wide. Figure 3 is how wide? 4 wide. And we figured out figure 4 was how wide? 5 wide. So figure 1 must be how wide? How wide must figure 0 be if we follow the pattern? We keep the pattern going and we work our way backwards. How wide should it be? Only 1 wide. And how many boxes should it have? We said how many boxes? Look, 3 boxes, only 1 wide. So that means that figure 0 just goes 1, Oops, I got to make the size bigger. Sorry. 1, 2, 3. It's only 3 wide, 3 tall. It's 1 wide and 3 tall. All of them were tall, right? So we drew the figures on the paper. Now we're going to translate those numbers we just did onto our table. So figure 0 was 3 boxes, right? So we input figure 0, we got 3 boxes out. We input figure 1, we get how many boxes out again? What did we say up above for figure 1 for total boxes? What did we say up above for total boxes? 9. Okay, figure 2 we said is how many total boxes? Come on, guys, look up above. We already wrote it down. We're just putting it in the table now. What did we say for figure 3? 15. Okay. What did we say for, oops, figure 2? I apologize. Figure 3, what did we say? 21. Figure 4, what did we say? So, did we do figure 5? Did we make figure 5? Did we make a figure 5? Did we make the figure 5? No. But can we figure out how many would be in 5? Yes, because we followed the pattern. So what's the pattern? How much am I going to add? Yes, 27 plus 6. Total of how many boxes in figure 5 do we expect? 33. Okay. So we changed the visual pattern into a table, and now we're going to go ahead and take the table like we did yesterday, and we're going to make the rule. We're going to make the rule for this table. First thing we look at is our changing between our y's. We said already multiple times that this is a plus 6 over and over, right? But that tells us what goes in front of the x, the 6. But remember, we talked about it yesterday, that the looking downward tells us our start. So it is going to start by looking at how much downward it goes. What does our figure start at? What did we do? How much did we add to 0 to get to our first number? 3. Okay, so we're going to add 3 to the back and times by 3 in the middle. So our equation goes y equals 6x plus 3. Because it's 6 times the column. So figure 1, 6 times 1 plus 3 makes 9. Figure 2, 6 times 2 plus 3 makes 15. Figure 3. Okay, so the figure number is your x. The figure number is your x. And the tiles out is your y. So if I said figure 10, I would do 10 for the x, 6 times 10 plus 3 more. Okay. If I said 100, 100 times 6 plus 3 more. Okay. That's what that equation does. Now we got to look at the graph. We're going to go put it on the graph. So I got to be a little bit smaller so I can fit. Okay, I am going to go graph these points that I just put on my table. Okay, the points that I just put on my table, we're going to put on the graph. the figure numbers at the bottom, starting with 0 all the way to 5, just like our table does, starting at 0 all the way to 35. Okay. So I'm going to make my dots red. I'm going to have my size at like 4. Okay, when figure 0, that's right here on the corner. How many tiles am I going to go up for figure 0? How many tiles am I going to go up for figure 0? What did we say figure 0 was? How many in the first picture? 3. Okay, so I'm going to go up by 3. 1, 2, 3. Okay, so what coordinate is this? 0, 3. Okay. Now we have to do figure 1. How many tiles in figure 1? What did we say? Look at the table. Figure 1 has how many in it? Nine. So I'm going to go straight up to the number 9, which is 1 less than 10. And then I go get my coordinate, 1, 9. Figure 2, how many? Look at the table, still at the top of the screen, 15. So I'm going to go up to 15. Boom. Coordinate, 2, 15. Okay, where's figure 3 going? According to the table, where's figure 3 going to go? 21. So keep going up the line. 20, 21. Oop. Sound effects make things so much more fun. That is figure 3 is 21. Okay, figure 4. Where am I going to be? 27. 25, 26, 27. 25, 26, 27. Okay. And that was 4, 27, right? Okay. And then we have figure 5. Where's that one going to go? Ooh, that one's in the wrong spot. I got to fix where it's at. 25 is here. 26, 27 is there. This is the hard part. 25. Oh, it was right. It just looked weird. Okay. So where are we putting figure 5 again? Look at the table. What did we say? We figured it out for the table. We didn't draw it. We figured it out for the table. $33. So I got to go up the 5 line. Keep going, keep going, keep going, keep going. So there's 30, 31, 32, 33. And we put our coordinates, 533. Now, would I connect these with a line? Based on what we talked about yesterday, would I connect these with a line? Does it make sense to use every number in between? Because remember, when we connect with a line, it means all the values in between can be used. Is there going to be a figure 1.5? Is there going to be a figure 2.6? Is there going to be a figure 3.7? Is there going to be any partial figures? Would there be any partial figures? Does part of a figure make sense? No. So we are not connecting these with a 9. Because if we did, we would say part of a figure was okay, but part of a figure is not okay. Okay, part of a figure is not okay. Later this week, we'll learn what the actual name is for leaving the graph as just the points like this. Okay, but I want to keep remembering we don't connect unless part of makes sense. Okay, we don't connect unless part of having a part of makes sense, and having part of a figure doesn't make sense. Okay, we already figured out how many tiles will be in figure 5. What did we say? There will be, how many tiles did we say figure 5 was? 33 tiles in figure 5 because it says justify your answer in at least 2 different ways. What was one of the ways? What was the way we figured out why it was 33? What did we do first to figure out 33? That's one of our ways. We know figure 4 had how many? Because 27, and what did we do to it? Six to get 33. Okay. Also, we're going to use that formula that we figured out. Okay. We're going to use that formula we figured out. We're going to go do the math of it to show. Okay. Also, y equals 6 times figure 5 plus the 3 would be y equals 30 plus 3. So figure 5 would have 33 tiles. Okay. So we use the equation and we used what we noticed from before, the adding 6. Okay. So now we're looking at figure 100. What should it look like? So how many, what's its shape going to look like and all that? And how many tiles should it have? And then we're going to do the last piece. So let's refresh the look. Okay, the look went, the figure number plus 1 was how wide, right? Right? The figure number plus 1 was how wide it was. We knew we always had 2 on the top and 2 levels on the bottom. And then we were repeatedly adding 2 to the middle. So figure 1 had how many in the middle? 1 in the middle. Figure 2 had 3 in the middle. Figure 3 had 5 in the middle. So what are we noticing we did? As we went up a figure, how many? We were adding in another 2 to that middle, but figure 1 had 1. Figure 2 had 3. Figure 3 had 5. Right? Figure 4 had 7. So I would expect that pattern to keep going, right? Okay, so figure 1 had the first odd number. Figure 2 had the second odd number. Figure 3 had the third odd number. Figure 4 had the fourth odd number. So if we keep going, what would the odd number just before 100 be? Because the 100th odd number would be what number? So let's talk what we do know, though. The 100th figure, oh, figure 100, let's do it that way. Figure 100, that's how they worded it. Would look like a big C with 2 rows on the top and bottom, having, how many tiles wide would it be? How many tiles wide would it be? Remember, figure 2 was too wide, figure 1 was 2 wide, figure 2 is 3 wide, so it's 1 more than the figure number. So how wide is the 100th one going to be? So it looks like how wide we are is 1 more than our figure number. So how wide? With 101 tiles and a middle that is how tall? How many numbers are going to be in that middle? So let's look something. Let's see. Let's see if we can make a connection. Okay. 3 wide, 3 tall, 4 wide, 5 tall. Didn't work that way. Does anybody know what the 100th odd number would be? Because this is going 1, 3, 5, 7, right? If we keep that pattern going, 1, 3, 5, 7, what would the 100th odd number be? Anybody know? Okay, let's look. We took figure 2. That's a 2, and it's 3 tall. 2 is 3 tall. 3 is 5 tall. 4 is 7 tall. 2 is 3 tall, that's 1 extra. 3 is 5 tall, that's 2 extra. 4 is 7 tall, that's 3 extra, right? So 1 figure less, 1 number less than the figure was added in. Okay. So anybody yet figured out what the 100th odd number would be? We take our numbers and we divide them too. Take our numbers and we divide them by 2 because odd is every other one. No, the 100th one, not the one before 100. 99 would be the 50th odd number. Okay, so we have to take the number and actually, to go 100 odd numbers, we'd be going every other one. So we'd go twice as far. Okay, so we talked about what it looked like, how many tiles it's going to have. So total tiles. We're going to use our formula for that. Okay, so y equals figure number times the 6 plus 3 more, right? Ooh. $603 tiles in it. We know this because we used the rule. And I'm going to change the size of this so it fits. Okay. So the rule is super helpful. The rule lets us go ahead and figure out stuff. Okay. Okay. So we're now on our next one. We had our table back here. See, this was question 18. Okay, we made a table, right? So we're looking back at that table in the rule. Okay. And we're working on answering questions. Okay, and this is where we get into why it's only dots. So Jessica prefers to keep the graph of the tile pattern as separate points. This is called a discrete graph. Why might a discrete graph be appropriate? Why did we say only dots don't connect with a line? What did we say? We said it earlier. Why did we say only dots don't connect with a line? We brought it up earlier. Okay. No, we don't connect only because it's a proportional relationship. That's not what I said earlier. Why are we not connecting? Because you can have a proportional relationship that is discrete, that you just keep the dots. What did I say earlier? Why is this different than our tree problem? And we talked about it earlier. Does it make sense to say figure 2.1? Does it make sense to say figure 5.7? Yeah, we only connect the dots if partial things are possible. Thank you, Lily. So a discrete graph is appropriate. Oh, I want to put my size bigger again. 1 second. A discrete graph is appropriate. Make sure you spell it like they did. It's hard to. For this data, because part of a figure does not make sense. Okay, we only connect if part of makes sense. Okay, and it is if part of both things make sense. Does it make sense that we could have part of a tile? No. Okay, so we can't have part of a figure or part of a tile. Does not make sense. Okay, so that's why we can't connect them with a line. Part does not make sense. Okay, she thinks figure 6 in the big C's will have 40 tiles. So we need to figure out if she's right. What is one way we could figure out if she's right? Using what we already know, what is one way we could figure out if she's right with 40 tiles? What could we do with some of the information we already have to figure out if she's right with 40 tiles? How can we build on what we already have to figure out if she's right with 40 tiles? Okay, we could take 5 and add 6 to it. So figure 5, add 6. would be, how many was in figure 5? How many did we say figure 5 had? Okay, figure 5 was 33, and if we add 6, we get what number? $39. Oops, 39. Yes. Okay, so that's showing, oops, she's made a mistake. What's another way we could figure it out with some information we already have? Because it says show 3 different ways. So one way we could, add 6 to figure 5. I mean, you could draw it out, but why? That's the same thing as adding 6 to figure 5, right? It says we need to use our rule. So how would we write our rule? Y equals 6 times what? Which figure are we using? Which figure did it say? Should see more people participating in the chat if they want their participation points. So what are we going to put in for X? X is the figure number. So what are we putting in? X is the figure number. So what number are we putting in for X? 6. Okay, and then we're supposed to add 3. That's our rule. So what is a 6 times 6? Well, 36 again. And then plus the 3, 39. Okay, so we figured out, oops, we added 6 to figure 5, not 40. We used our rule, not 40. Okay, last way we're going to do, we're going to add a point to the graph. So we're going to go back up here. Now, if you notice, it's 1, 2, figure 6, we're going to put in this line right here. Okay. Okay, so if we added 1 to our line, we'd be up here off the graph, right? Okay. So we would be adding what data point? What would be the coordinate number we would add? Since we can't actually put it on our picture, there's not room on our graph. What coordinate are we going to say we're adding to our picture? What coordinate would we add to our picture? If we had space, what coordinate will we be adding to our picture? $639. Because we don't have space. That's not what I want. I want this. Coordinate. Okay. So she's not right. She's not far. I mean, she was close, but she miscounted. So Frangelica is incorrect. Figure 6 would have 39 total tiles. We solved this or proved this. We could say that, proved this using the table, rule, and graph. Okay. Okay, we got another one we have to prove. Giovanni thinks the point 1699 is going to be on the graph. Now, what does the 16 stand for? What does the 16 stand for? In our coordinate pair, the first number stands for what thing? In the coordinate pair, the first number stands for what thing? The figure number. Okay, so this says figure 16 will have 99 tiles in it. So do we think that he's right? So it says to use our rule to check if he's right. Okay, so let's see. What was the rule again? Let's write down in the rule again. Y equals 6x plus 3. That means 6 times a figure plus 3 more, right? So we're going to replace the x with the figure number. So what are we replacing x with? For this particular question about Giovanni, what are we replacing the x with? The figure number. So what am I going to put in there? What number am I going to put in this spot of our formula? Because we're figuring it out, 16. Okay. And then we go out of the parentheses and we're going to add 3. So we need to figure out what 16 times 6 is. What is 16 times 6? What is 16 times 6? $96. Okay, thank you. Okay, so this says 96 plus 3, right? So how much is 96 plus 3? $99. So was Giovanni right or was Giovanni wrong? Giovanni was right. Okay, so let's go do our text box and claim Giovanni's right. Giovanni is correct. Figure 16 would have 99, total tiles. We used the rule to check his coordinate, right? All right. So now we have Jeremiah. Jeremiah thought the equation was x plus 8. Okay, so what does the x stand for again? What does the x stand for again? The figure number. So we have to check, maybe this is an alternate option, okay? So we're gonna check his equation, his rule that he found, by putting in a couple different figure numbers and seeing if it comes out. Okay, that's how you double check a rule. You put in some of the figure numbers and check to see if it works out. So let's look. If we put in figure number 1, that'd be 1 plus 8, right? So that means that figure 1 would have 9 tiles in it. Can we go back and look? Did we say figure 1 had 9 tiles? Yes. So that worked. Okay, now we're going to check figure 2. Figure 2 plus 8. Okay, because we're using his rule and checking his rule. Does figure 2 have 10? So let's look, compare it to ours. Does figure 2 have 10 in it? Does figure 2 have 10 in it? No. So did his rule work? Was his rule a possible alternative? No. Okay. So let's go get our textbooks. Jeremiah is incorrect. Oops. With his rule of y equals x plus 8. It only worked for, which figure did it work for? Which figure did it work out for? Figure 1, but none of the others. Because even if we put figure 0 in, right, we could do that one. Figure 0 would have been, whoop, I did the wrong thing. Y equals 0 plus 8. 0 plus 8. That would have meant that figure 0 had 8 in it. And did figure 0 have 8 in it? So it did not work for figure 0. It did not work for figure 2. It only worked for figure 1. Okay. So that's one of the big things is when you think you've got your rule figured out, you need to test it on the other points on your table, because maybe it's a temporary rule, not a real rule. Okay, LaTanya has been thinking hard and found another rule for the same pattern. Another rule for the same pattern. She is sure that y equals 3x plus 1 is correct. Prove or disprove her position. So we're going to do the same thing to LaTanya's that we just did to Jeremiah's. We're going to look at 0, and we're going to look at 1, and if we need to, we'll look at 2. Okay. So y equals, the x stands for the figure number, right? 3 is still there. 2 times the 0 figure. We're going to start with figure 0. Plus 1 more, close it. So this says y equals 3 times, what's 0 times 2? No, yeah, 0 times 2. What's 0 times 2? 0. 0 plus 1 means my parentheses is worth 1, right? Because I had nothing to add in. So figure 0, 3 times 1, 3. Did that work out? Did that check out? Yeah, that checked out. So up here on Jeremiah's, figure 1 checked out, but figure 0 and figure 2 did not. Okay. So this worked out. Figure 1, figure 0 worked out. We're going to go check figure 1 now. If 2 in a row work out, then you don't have to test anymore. Okay. So y equals 3 quantity 2 times, if I'm doing figure 1, I put a 1 in, plus the 1 more because that's her equation. Y equals 3 times. This says 2 times 1. What's 2 times 1? 2. Okay. So that means we have to do our parentheses rule because I see a plus or minus in a parentheses. So I have to clean up my parentheses. What is my parentheses clean up to be? If I combine my parentheses to one number, what is it going to be? 3. So y would equal 3 times 3, 9. Did it check out? Is that on our table as well for figure 1? Yes, it is. So it checked out again. So remember what I said, if it checks out 2 in a row, you're good to go. So yay, that checked out again. So is LaTanya right? Is her rule an alternate way of saying the equation? Is that another rule form? Yes. So LaTanya has a correct rule in y equals 3 parentheses 2x plus 1. Oops. 2x plus 1. We know this because we tried it out with figures 1, 0, and 1, and both checked out. Right? They worked out. They were right. So there is more than one way you could see, but this should be a 2 right here. I'll fix that. Okay. There is a way to rewrite rules into different formats. This is a distributive format. Okay. The other one was just a standard format. Okay. Questions about those notes? Okay, turn them in, please. Done or not. Every time you do them, I'm expecting at least 75% of what I get done. Okay, so any questions?